It's hard to believe that we're almost done the semester. I think there's only one full week after this before finals. So we're almost there, but we have a lot more material to cover. And in this chapter, we're going to be talking about ionic solutions. We're going to be talking about strong and weak acids. So a lot of important material here. We're going to start by talking about electrolytes and conductivity in this brief video. So you've probably seen or done an experiment like this, in middle school maybe, where it's just showing, right, if you have two wires that, like copper wires, when they touch, you're going to conduct electricity. All right, the light bulb in this case is going to turn on. That's connected to a battery. And of course, if you detach those wires from each other, there's no conductivity, right, of the electrons in there. So the circuit is broken and the light isn't going to turn on. Okay, that's obvious, right? For many of us, especially if you had like a wiring problem or something like that, or some wiring maybe in your house or even your car is not quite working and you have to fix it. So, okay, what does this have to do with ionic solutions and strong and weak acids, like I said before? Well, we can have electrolytes, all right? That's something maybe you heard about in Gatorade, right? You have lots of electrolytes in Gatorade or Powerade. So if we had a solution here, right? This is just ethanol. Oh, excuse me. If we had a solution of ethanol, right, in here, and we had two wires, if you would, that are not connected physically, two strips of metal here that connect to a light bulb. Ethanol is a non-electrolyte, so it doesn't conduct electricity because it has no ions in the solution, okay? And that's why it's really key that we understand ionic solutions and strong and weak acids, because it will help us to predict if something is going to be a good electrolyte. A strong electrolyte conducts electricity, okay? So in this case, we have copper chloride dissolved in solution. It has this cool blue color in here. And so this is a solution that's made up of water molecules, of course, but also copper ions and chloride ions. And the key here is that the copper chloride is completely dissolved into copper 2 ions and chloride ions. And this is something we're going to talk about as we go through these videos, okay? But for a strong electrolyte, it's completely dissociated in solution, okay? It exists only as ions, the copper 2 chloride. If you look now to a weak electrolyte, this is acetic acid. Okay, it can break down into the acetate ion and a proton. Okay, so this is something we're going to talk about more when we get to our video on acids in this chapter. The light bulb is much weaker, the brightness of the light bulb. And a weak electrolyte conducts electricity poorly because there are so few ions present in solution. So here's the proton in this case, and here's the acetate ion, but there's much less of them, okay? Much less ions for a weak electrolyte. So it conducts electricity poorly, okay? Whereas a strong electrolyte, there's a lot of ions and the electricity is conducted very well. And again, this is maybe an experiment you did in middle school again, where you maybe made a battery out of a lemon or something like that with pennies, or maybe a potato. I know a lemon works, but you tested different vegetables and things like that. It's the same concept showing up here again. Okay, so conducting solutions, the takeaway is that conducting solutions contain ions, okay? So that's a key takeaway for us. And the extent of conductivity, this is something I already said, but I'll repeat it, is related to the concentration of ions in solution. Okay, so again, a strong electrolyte, the ions completely, or the material, I should say, completely or almost completely ionizes or dissociates in solution. So things like, in this case, it's potassium chloride, that salt completely dissociated in the solution. A weak electrolyte, like the acetic acid example, does not completely dissociate in solution. And then, of course, a non-electrolyte there's no dissociation into ions. So like the ethanol case, it was a very poor electrolyte. So like I said, short video, just giving us the basics of what we mean by conductivity and ions and why they're important. And now we're going to look in the next video more specifically at solutions of ionic compounds. So I'll see you there.